Hi there, everybody. Thanks very much for the introductions, and thanks for tuning in, everybody. Given the challenges we've been dealing with this pandemic around the world for the last 6 months, it's no mean feat just to even get the event hosted at all. So well done to the hosts. So in the next 15 minutes, I'll share some of my personal observations, maybe with you, and those of Jacob's around some developments we've been, seeing gathering pace over the last 12 months, particular integrated catchment management, the role of technology within, and then maybe cast an eye forward to how we see the potential over the next 5 to 10 years to really deliver better outcomes for our communities. Hope this maybe sparks some ideas with everybody, and from what I've seen in the conference so far, I think it should tie in. So systems thinking today and tomorrow. So integrated catchment management today, or systems thinking today, if you like, is fairly well understood concept, which I think translates pretty consistently around the globe. It's something we've been involved in for some years in terms of the solutions, the concepts, and the science, whether it's networks or flood management, or of course the integration of the two. But in the last 3 to 5 years, and in particular the last 18 months, we've seen an explosion of technology with development and deployment of sensors and analytics platforms into the market, which is adding a new dimension to integrate, to what integrated catchment management can be. The deployed technology across asset bases is also becoming increasingly proven, and it's got a continued reduction in the cost of the IoT devices themselves. So the rate of deployment looks like it's going to continue to accelerate. And of course, there's investment in the associated analytics platforms as well to enable the value to be extracted from the data, if you like. So, and of course, there's varying degrees of maturity here, and more mature the model, then probably the closer to wider societal outcomes we're delivering. But you've got early adoption of relatively simple single asset type devices with remote notifications, to more integrated wastewater control solutions, which are more mature. These are regional catchment levels, and you're talking about multiple assets, multiple data sources, and the application of machine learning and AI, in terms of helping with automated decision making and controls. So, key point is really that with more integrated real-time AI-driven capabilities available across linear and fixed assets, we're actually getting to the point where we're, starting to deliver better customer and shareholder outcomes. So, and on a slight aside, but also of interest here, is the fact that infrastructure investments funds seem to be actually very interested in these types of solutions. They're very interested in investing in these and the long-term returns through sort of data as a service type models. So look, the need seems to be there, and the funding is there as well. So we can see continued growth in sort of real-time ICM supported by this technology. And to really achieve the true step change transformation, was going to involve transforming the workforce and the supply chain as well. And that's a whole other discussion for another day in reality, but it's an interesting one. But like the key thing is we need to recognize the human aspects here. So this is all good, right? If we can get up to the AI optimized societal benefits, integrated solutions, well, job done. Well, actually, we think there's another step that we can go here, and take it beyond it. So, what is it that tomorrow looks like? At the moment, we're talking about integrated assets. But how do we talk about integrated outcomes? And these are the sorts of questions we're challenging ourselves on, frankly, and having conversations with clients and regulators around. So, what I've talked about very much so far is about, networks and water systems, whether it be cleaner wastewater. And these are definitely central to the outcomes and catchments. But there are many, many other assets and many, many other sources of data out there. There are many better and more ambitious outcomes we can deliver by adopting a systems thinking approach, in our view. So what does tomorrow look like? How do we get to more integrated water cycles and those sort of digital twins at societal level? What if we could connect all the other assets, data sources and services for the benefit of society? What would be the outcomes we could deliver when we cut across the asset and the organizational boundaries? At the end of the day, the context here is that ecosystems, biodiversity are under pressure, our finite resources are under pressure, and frankly, the economy's under pressure, may well be for some significant period of time post-pandemic. So, these wider, greater benefits, nobody's saying these are easy, they're complex, but actually I think even in the work that we've been doing and many other people attending the conference here, the benefits outweigh the headaches of getting there. So we actually think it's something that we all get, but it's worth all getting behind. But really what we're talking about here is sustainable solutions, genuine sustainable solutions. And that's why I've sort of thrown up here on the bottom, the United Nations Sustainable Development Goals, because I think they give quite a good flavour and perspective on the types of benefits. We need to be multiple benefits we need to be delivering to our societies. So we'll maybe use that as a little bit of a dashboard as we go forward, but without going through them in detail, just basic things like good health and well-being, affordable clean energy, sustainable cities and communities. These are actually intrinsically linked to what we're talking about here, and the solutions and assets and outcomes we're all passionate about delivering. But before we get into looking at a couple of examples in terms of what we think systems thinking could look like in the future, just relatively simple schematic here to give some understanding of the complexities of interactions here. And this isn't showing a whole catchment, this is just showing an exemplar of the type of assets in a catchment, obviously, but and this comes from Replica, which is sort of our own sort of in-house digital twin solution, which sort of combines our domain knowledge and sort of computational power. And we use this to optimize energy and chemical usage and processes, or maybe develop control strategies for weather events, through sort of digital twin approach. You can see the complexity here around, water, runoff, water resources, drinking water networks and processes, wastewater networks and processes, multiple energy assets, and sometimes finite resources in the system as well. So it's just a flavour because it's conceptual and schematic. But if we sort of go a little bit more conceptual and think a little bit more into the future, we've actually got quite a rich source of data already. And as we've sort of talked about before, with the cost of IoT devices coming down and the advent of 5G upon us, that's probably only going to get richer. So that's the context for how we should be thinking about solving solutions. Well, variable permitting is one of the areas that we think we could potentially cut across some of the assets and boundaries and get to a better outcome. Generally at the moment, from a UK discharging permitting perspective for wastewater treatment, is typically at a single asset, a single discharge point, to a degree in isolation and to a degree with relatively fixed compliance limitations. But if you think about the data capture, communication analytics, and the sort of predictive assessment capabilities as they are now, well, why not have a more holistic approach to this that's more dynamic, with more real time? Why can't we manage the systems and the storage ahead of time for storm events that we know are coming from weather data? Conversely, when we've got low flow events and no incoming weather events, why can't we optimize the treatment? If you add in what real-time water quality data in the natural environment like the river and the man-made environment, you can actually get to the situation where we can actually get the possibility of dynamically utilizing the assets across the catchment to flex the discharges up and down in relation to variable quality of and volumes and inflows and outflows within the water wastewater system and the river. So that way we're only treating what we need to, and we're only treating it to the standard we need to, which must be the optimal way to utilize our resources while maintaining the ecosystem. And as you can see on the little conceptual dashboard at the bottom, again, would address a number of the outcomes we're seeking to deliver here. So another area, and I think this thinking, the circular economy principles link well to systems thinking approaches. The move from linear to circular thinking, maximising use and minimising waste. But wastewater treatment works, they should be viewed as energy generation facilities. They should be viewed as water reclamation plants. And actually that goes beyond into material flow principles as well. We can be extracting phosphorus, grit, other biosolids, all things that can actually be valuable resources for other applications in our catchments, and again deliver multiple benefits. And finally, what about better infrastructure planning? There's got to be a better way here. If we took a systems thinking approach to better infrastructure planning and we brought together some of the examples we talked about plus others, create a strategic planning framework where we can actually genuinely optimize the existing infrastructure first before committing to new capital intensive solutions. That's got to be a more sustainable way to enable growth. But again, it needs systems thinking principles. But if we can plan, by planning assets within natural organisation and regulatory boundaries, we're merely limiting the solutions we can come up with. So the possibilities when expand our horizons and work across more boundaries are huge. If we can combine the natural and man-made system assets and look at them collectively but without boundaries, the possibilities are significant. Maybe we can actually get to that point when we deliver truly optimized, integrated infrastructure, sort of systems of the future that are fit for purpose. So master planning with a digital twin, boundaryless and integrated in nature, that's an ambitious goal. So if we get this right, we're fundamentally building resilient infrastructure systems for the future that are, to our mind, more agile and able to rapidly adapt to changing situations, which more traditional infrastructure solutions are not really being able to deal with. And the recent pandemic only reinforces that when you look at some of the rapid changes in societal norms. So, in our view, there is a need for a better way of planning and implementing infrastructure. And this is a sort of longer term way of thinking about systems thinking versus the real near term, if you think about the variable permitting. So all of it falls within that bold ambition of systems thinking approaches. So what are the takeaways? So look, technology enabled integrated catchment management is here, and if you get to the mature end of the scale, which we're already seeing in places across clean and wastewater networks, we're starting to leverage relatively cheap IoT devices and platforms, sometimes data as a service models, and we're getting to the point where we can transform customer service, real-time, plan predictive, real-time inventions, these they're the platform for an invisible service for the customer, which is what most customers, to our mind, would like to see. And even these solutions as they stand, these platforms can provide a skeleton upon which more ambitious integration across assets, data and stakeholders can be delivered. But what unlocks this future systems thinking, the bigger prize, is partnership and collaboration. So it's no coincidence if on my dashboard and my slides that goal 17, that collaboration and partnership was highlighted each time, because the UN recognise that the SDGs need strong global partnerships and cooperation. And the examples we talked about all need cross-sector, cross-client and cross-regulator cooperation to deliver them. So, I'm quite fortunate here at Jacobs that, collaboration is kind of heart of how we do business, and also fortunate that it combines the breadth of domain knowledge across these sectors. So, collaborating to enable partnerships without boundaries is key to these solutions. And, we are trying to, and we want to work more with organisations who share this, our vision to deliver these solutions for, that our communities deserve and which we believe are within reach. So, and this is very well aligned, I think, with the principles the United Nations are trying to deliver here, which is, this sustainable development agenda requires global, regional, national and local cooperation, and it needs to be built on common principles and values, shared vision and goals, placing people and planet, at the centre. So thank you very much for listening. I'm out of time. Hopefully the pace was okay for you. And thank you very much for listening. Please don't hesitate to reach out to me into the future. I'll be more than happy to pick up the conversation with you.